All right, so we're going to talk about some of the most missed questions from Friday's test, starting with number 3. So this question says, which of these atoms is electrically neutral? So I think this word neutral kind of threw us off because we were thinking of neutrons, but remember neutral just means no charge. And because we're talking about this word electrically, we know that it's either going to have to be positive, negative, or neutral. So we have our positive protons, because remember protons are positive, and we have our neutral neutrons, and we have our negative electrons. Since the neutrons are already neutral, they aren't going to affect the overall charge of the atom. So we're looking for the one that has the same number of protons and electrons. So that's ape. The atomic number equals the number of protons, which equals the number of electrons. So for our answer choices, if we look at A, we have 4 positive protons and we have 3 negative electrons, which means that if we looked at our overall charge, it would be 4 positives and 3 negatives, so that would give us an overall charge of +1. So this one is not neutral because we have a charge that is not 0. So for B, we have 4 positive protons and 2 negative electrons. So if we look at it this way, we can cancel these out, and we're left with a positive charge of +2. If we look at C, hopefully we're getting the gist of this here. We have 3 positives and 4 negatives. So what would you say is the overall charge of this one? Go ahead and answer that question. If you answered that the overall charge was -1, you are correct. Which leaves us with our last answer choice where we have 3 positives and we have 3 negatives. And since they all have a pair and they all cancel out, we have an overall charge of 0, which is neutral. So our answer for 3 would have been D. Number 4 says, which of these atoms has the least mass? So we're looking for which one has the least mass. We know that most of the mass of an atom is found in the nucleus. So most of the mass is in the nucleus. Remember, those electrons are so small that they really don't affect the whole mass of an atom because they're so insignificantly massive. So if we're looking for the nucleus, we're really looking for, this question says, the least mass, so we're looking for the one that says the least stuff in the nucleus. So F, if we count, we have 1, 2, 3, 4, 5, 6, 7. So we would have a mass of 7 AMUs. For G, we have 1, 2, 3, 4, 5, 6, 7, 8. We have a mass of 8 AMUs. For H, we have 1, 2, 3, 4, 5, 6. 6 AMUs. And for J, we have 1, 2, 3, 4, 5, 6, 7. 7 AMUs. So H is the one that has the least amount of mass. All right, number 5. This one was really tricky. This was multiple steps, and so I know that we kind of got a little confused on this one, so we're going to walk through it right now. So number 5 says the table shows information about 2 atoms, X and Y. How can these 2 atoms have the same atomic mass? And our answer choices are A, atomic X is a liquid and atom Y is a solid. B, atom Y has 1 more proton than atom X. C, atom Y has 1 more neutron than atom X. Or D, atom X is a metal and atom Y is a nonmetal. So just by looking at this table, it says that we have atom X has an atomic mass of 14 and 7 electrons and a charge of 0. So this part right here is important, this charge of 0, because that means that this is a neutral atom. And if it's neutral, just like question number 3, that means that it follows ape. Atomic number equals the number of protons, which equals the number of electrons. So if the atom X has 7 electrons, how many protons does atom X have? It should have 7 protons as well. So X has 7 protons. So same thing for Y. If atom Y has 6 electrons, how many protons should it have? It should have 6 protons. So if we know how many protons it has, now we can use the second part of our acronym, MAN, to figure out how many neutrons it has. So M, the mass number, minus the atomic number, equals the number of neutrons. So we should have a mass number of 14. So if we set this up like a math equation, it would look like this. We would have 14 minus our atomic number, which, because we know ape man, atomic number equals number of protons, which equals number of electrons. So if we have 7 electrons, we have 7 protons, which means our atomic number is 7. So we have 14 minus 7 equals how many neutrons? So atom X would have 7 neutrons. And then if we were looking at Y, we would set it up the same way. We'd have 14 was our atomic mass, minus 6 equals our number of neutrons. So atom Y should have how many neutrons? It should have 8 neutrons. Now I know something that happened with this was a lot of people went and looked up what that element actually is based on their electrons, because you used ape, which was great, but it gave us our mass numbers, and so we needed to use the mass that was given to us in the problem. So this is when we really want to make sure and look at what information does it already give us in our problem. All right, and then number 8. This one was a little tricky. A lot of people chose J for this one. They said most of the volume of an atom is made up of the nucleus. Now we know that the nucleus is the most dense part, but remember from our homework video, if you guys watched that from 2 weeks ago, our homework video talked about how actually the nucleus is really, really, really small. Remember, it compared it to being a blueberry, a little teeny tiny blueberry in a giant football stadium. This is my football stadium. Just go with it. Yay. So we have our blueberry in our football stadium. So the nucleus is actually really small. Most of the volume, which we need to make sure we understand what that means, most of the volume of an atom is actually going to be made up of empty space. But let's take a minute to define volume. So volume is the amount of space that a substance or object occupies. So it's how much space. So let's define that. The amount of space that an object takes up or occupies. So go ahead and take a second to answer this in your own words. So I want you guys to write a definition for volume in your own words. All right. Number 9. So this was actually just like the other one. So most of the mass of an atom, remember we're going to write this table and it's going to come in handy in our next question here. But the mass of an atom is found in the nucleus, right? Because if we look at our three characteristics of protons, neutrons, and electrons, so we have protons, neutrons, and electrons. We have the mass, charge, and location. So the mass for a proton was 1 AMU. The charge is positive, and it's located inside the nucleus. Then we have the neutrons. The mass of a neutron is 1 AMU. The charge was neutral, or nothing, and it's located inside the nucleus. And then we had the electrons. It was 1 over 1,840 AMUs. The charge was negative, and they were located outside. If you guys can remember this table, this is going to be your best friend when it comes to any questions about the characteristics of subatomic particles. But we're going to focus on the mass here. So which two have the same mass? It's the protons and neutrons. Electrons are so small that a lot of times this is going to be written as just 0. So it actually has nothing to do with the mass because it is such a tiny number that they're like, it doesn't even matter. Like it doesn't make a difference one way or the other. So we're going to look at just the protons and neutrons when it comes to mass. And so both of those are located inside the nucleus, so we're going to use number 11s here. So this is the nucleus in the middle, and that contains the protons and the neutrons. So for number 9, our answer would have been D. Same thing here, so number 10, it says an element's atomic number refers to, everybody really picked between H and J. And that's good because that both of those follow 8-man. And so we know that the atomic number equals the number of protons, which equals the number of electrons. The reason that H is the right answer for this one is because the number of protons, we're going to write it down here because it's super important. We need to write it really big. So protons determine an element's identity. So remember we talked about in 8th grade chemistry, protons are going to equal electrons because it is electrically neutral. But remember we talked about that that's not how it's going to be when you get to high school chemistry. Sometimes the number of electrons can change, and that's called an ion. The thing that can't change, though, is the protons. Because if I took one proton, that would be hydrogen. But if I change the number of protons and I said, okay, 3 protons now. If I change it to 3 protons, that's no longer hydrogen and it's lithium. It completely changes what the element is. All right. Number 16. Okay, this goes back to our table, so we're going to fill this in one more time. So it says that which subatomic particle has the least mass, less than 1 AMU. So again, if we know this triangle, we have protons, this table. If we know protons, neutrons, and electrons, we know the mass, charge, and location. The mass of a proton was 1 AMU. The mass of a neutron was 1 AMU. And then the mass of an electron was 1 over 1,840 AMUs. Right? Again, almost 0. This means that 1,840 electrons weighs the same amount as just 1 proton, which is kind of crazy. Awesome. All right, so those were our most missed questions from the test. They might not be the ones that you missed, but they are really important that we make sure that we kind of cover those, because if we can answer these questions, we will be able to answer any of the questions that have to do with atomic structure. Again, just to review, ape man, all right, I want you guys to go ahead and write out for me, what does ape mean? And what does man mean? What do these stand for? And then our table. So one more time, we're going to go through this together. We have protons, neutrons, and electrons. We need to know the mass, the charge. Oh, I spelled charge wrong. It's okay. And the location. The mass of a proton is 1 AMU. The charge is positive, and it's located inside the nucleus. The mass of a neutron is 1 AMU. Its charge is neutral, or nothing, and it's located inside the nucleus. And an electron, the mass is 1/1840 AMUs. It's negatively charged, and it is outside the nucleus. So if we were to draw this, we would have our protons and our neutrons located inside, and then we would have our electrons. If I've got 1, 2, 3, 4 protons here, then I'm going to have 1, 2, 3, 4 negatively charged electrons on the outside. Alrighty. Thanks for listening, guys. Make sure that you answer the questions at the end, and if you have any other questions about the test,